let me just start with the gating. So I think I can make it. So let's just go through the first part of the gating, just get the principle of gating, and then we can open up LSTM and GRU next time, right? As a kind of review how gating works. So what is the idea of gating? Well, yeah, this was the vanilla RNN that we use. We basically go over this guy, and we said that we have a small memory. That's nothing specific that we want to talk about here. But now let's see how gating works. So let's get back to the example that we had. We had this example at the very beginning. And what was the example? So you had this person who was Yulia, has been nominated, blah, 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 for something, right? And then we said if the neural network really wants to understand that it should put her here as the next word, it somehow needs to understand that the sentence is talking about a female, right? And it's a third person, single person, so I am supposed to put her here, right? Now, this means that it needs to have a memory which knows about Yulia, and Yulia is somehow clear in its memory, right? Now, if we have a vanishing gradient, and Yulia has happened a long, long time ago, this means that the gradient that you are computing is having very minor impact by Yulia, right? So it means that your RNN is not really having long memory enough to remember it was Yulia, right? Even though theoretically it should be able, yeah, not should be able, but it could be able, right? But in practice, you cannot do it simply because of the vanishing gradient, right? Now the question is can we do any way that we somehow keep Yulia fresh inside the memory up to the point that we get there? Is there any way that we can do it? Well, right. So here is what's going to happen if we do it by basic RNN. Obviously, the basic RNN is not going to carry Yulia. And the question is that how we can do this if we want to just, if we do know that Yulia is the important thing, right? For now, just think about a kind of thought experiment. So let's start with this thought experiment. The thought experiment is that I really do know that Yulia is important, right? And then I have this extra degree of freedom. At every single time, I have one variable u. Okay, this is the gating variable, but you're going to see why we call it gating. So this u is a number between 0 and 1. Okay, and every single time, every single time step, in addition to the input and the hidden state and everything else, I have this u as well, right? So I can choose u by my own, this is my choice, to be some number between 0 and 1, right? Now, I get to Yulia, and I see that Yulia is a very important term for me, right? So what I'm going to do, I'm going to get u to be 1 at that time. So say Yulia happens at time t0, I'm going to put u t0 to be 1, right? Now, when I do that, then next time that I go in time, like I go for the next word, I see it has, I say, oh, who cares about has, right? I'm going to set it 0. Bin, who cares about bin? I'm going to, everything in between Yulia to the word that I want to predict, I'm going to put it simply 0. I'll put u value for it to be 0, right? Say I do that with this u variable, then let's see if I can use this u variable to somehow modify my computations to get somehow fresh memory of Yulia. So now I'm going to use my u in this form. So I'm going to have the same recurrent neural network as before. So every single time I get my input, I multiply it with its own weight. I also get my previous hidden state, I multiply it with the memory weight. I do the activation, so I compute a new hidden state, but I do not really update my hidden state immediately like that. I'm going to get my hidden state, this row hidden state that I computed, h tilde. I'm going to multiply it with u, right? That number between 0 and 1. And then I do moving average with the previous ht minus 1 that I had, right? Now, what's going to happen if I put u 0 at one time? What's going to happen? if u is 0, the hidden state that I computed at that time is simply getting ignored next time, right? And what is my hidden state then? Say I am at time t, right? I compute h tilde t, and then say u at that time is 0. Then that u is getting multiplied to h tilde. It's going to make it 0, right? Whatever I computed at that time as a hidden state, it's going to get ignored. And what comes out as a hidden state? ht minus 1, right? So I'm going to keep the memory that I had in the previous time, right? So I'm at this time. If u is 0, I ignore whatever I computed. I keep the memory that I had the next time. I copy it here, right? If I have u equal by 1, exactly what's going to happen? The previous memory is going to be ignored, right? That guy is totally multiplied by 0, right? I'm going to get whatever I computed right now as my memory, right? Everybody's cool? Everybody sees what's happening? Okay, so given that, let's see what's going to happen to Julia when we just do this gating, this approach here, like using u for update. So first time, I am at time t0, right? Julia goes inside my neural network. I'm going to do all the computations. At the output, I'm going to get one hidden state, and that hidden state, h tilde, is depending on the word Julia, right? So it has a fresh memory of this term, right? Now, I set u equal by 1, right, for that time. This means that when I want to update my memory, this is the step that I do the update. By updating the memory, I mean step 3 here, right? When I want to update the memory, I get h tilde, which is the fresh memory about Julia, right? I multiply it by 1, I keep it. I multiply the previous memory by 0. I just ignore it, right? Everybody's cool? Everybody sees that? Yes? Great. So at time t0, the thing that is going to happen is that my network is going to have a fresh memory, which is including information about Julia, right? Now, I go for the next time, right? In the next time, the word is has. I start to do all the computation with this word has, right? I get a new memory, h tilde, which is depending on has, right? But what I do, I multiply that information, that memory, by 0. It means that I ignore has, right? And I copy the memory that I had at time t0 about Julia. I copy it exactly at this time, right? Everybody's cool? I go for the next time. What's going to happen? In the next time, again, I set u to be 0, right? It means that I am computing information about the word bin, right? But at the end, I just ignore it. I copy whatever I had in the previous time. And whatever I had in the previous time, whatever I had on the second previous time. And that was fresh memory of Julia, right? So I'm keeping the fresh memory of Julia by me all over the time, right? Now, when I get to the time where I want to just predict the next word, if I just go all the way towards the time when I want to just give the pronoun for the person in the sentence, right? My memory remembers Julia very clearly, right? And I can understand that it should be her, not, for example, his or its or something else, right? Everybody's clear? Yeah, you got the idea? So this is what we call it gating mechanism. So why we call it gating? Because that u guy, which is between 0 and 1, is like a tap, like a gauge, right? You're controlling it. If you put it 0, this means that you just close the gauge, right? Nothing is coming out at this time. I don't need it, right? If you put it 1, it's like you open it completely. You can also open it halfway, right? Some number between 0 and 1, right? So you would say, okay, some fresh memory, something from previous time, because that was also important, right? Everybody's clear? So this is what we call it gating, right? And if you think about gating, you could see that it is basically doing implicit skip connection in time. How is it the case? Because when you want to compute the gradient of your hidden state at one time, you need to go one time back, right? You need to do this. But with the idea of gating, in the dummy example I gave you, at this time that you want to just take the memory, that memory is exactly the memory in the previous time, is exactly the memory in the second previous time, the memory is always the same up to Julia, right? Now, the gradient that you are computing is exactly the gradient of the hidden state you compute at time Julia, right? So it means that you somehow implicitly connected this time directly to Julia, right? Everybody's clear? So this is a skip connection over time. When you do gating, if you set your gate to be 0 at the time I, then your gradient at time I is going to be exactly the gradient at time I minus 1, because the hidden state does not change, right? And if you keep on doing it multiple times, then every single time you're exactly taking the same gradient, and now this one could potentially make the impact of vanishing gradient less, right? So somehow you're doing a skip connection, but you're doing it implicitly over time. Everybody's clear? Question on that? Yes, but then, I mean, we're going to see that later. But the key point is that even if you take something between 0 and 1, you have the fresh memory, and you have something from before, right? And that something from before is also taking one connection, right? Because your gradient, like your h at time t, is not simply computed by that activation term, right? It's computed by that one plus your previous h, right? And you have a direct derivative of ht minus 1 as well, right? So this is going to avoid that vanishing, or at least extreme decay in time is going to avoid it. Questions? So you got the idea of gating, right? So the only thing remains here is that how we can find out what is u. Obviously, you can expect that we are going to learn it, right? So we're going to give a bunch of weight to that guy. Is going to also learn how you can do the gating, right? And we are going to discuss about this next time, okay?